Hi everyone, I'm excited to share something. I have been building a memory first RAG platform inspired by the wave of products like Super Memory, Mem Machine. In the next couple of minutes, I will walk through how it stitches together with semantic memories and a live knowledge graph. And I also try to implement a Mem Machine style agent workflow. So this is my the code base, and there is my architecture diagram for the front end and for the fast API application. So the bigger picture is imagine this is a living knowledge layer for your AI assistant. On the front end, we have React dashboard and that gives the engineer a cockpit. You can write or upload documents, explore a lineage graph, search symmetrically. Everything you do, there a task to a fast API backend, which handle document chunking, embedding generation, relationship creation, mem machine session, storage, and super memory session, and a new asynchronous upload path so the UI never freezes. So in the architecture, every new memory fans out in two direction. In Neo4j, capture the relationship graph so we can model update, extend, and derive connection, track version lineage, and traverse the graph in millisecond. So in Chroma, it stores the embedding for semantic search, and I also try to glue the fast API with the memory service.py, and for graph embedding and for the rack service, I created a file as rack service.py for hybrid retrieval, and for the sync of episodic memory, I'm using mem machine API like memory.service.py for graph and embedding writes like I using heavy upload in the background. So the rack pipelines pulls together everything together. It blends vector similarity with lexical signals and a neighborhood graph summary when you hit the API. Like if you're uploading any good documents and if you're writing any query, so the response include not only the generated answer but also a subgraph snapshot. So the UI you can show why the specific nodes were relevant. So I also wired some use cases, and there are total like 6 to 7 use cases like chatbots, knowledge base, education, healthcare, customer support, and research tool. Each one support manual write to memory and file upload flows through the RAG embedding, and both parts create embeddings, update the graph, push the episodes to the memory, so the agent keep long-term memory across session. Let me show you the technology stacks. I'm using Fast API as I already mentioned, and ChromaDB for vector database for embedding storage, Neo4j for graph database for relationship management, and OpenAI sentence transformer for embedding generation, and also PDF Plumber for PDF text extraction, and in the front end React 18. So let's go through the quick walkthrough of the product, and it's the front end. Let's go to the dashboard. So it's my knowledge graph. I already uploaded some documents. Like if you can see this, hello, what is artificial intelligence? This session ID and there is user ID, and this came from chatbot source type. You can see what is artificial intelligence. It came from chatbot. So let me show you some more. What if we go for, and this came from machine learning, and I just uploaded my resume there. So you can go and see. Yeah. So this knowledge base came from the source ID abuhamzakhan.pdf, and it's through the RAG embedding. And this came from the file type PDF, and so the RAG is working. Let me show you. So it's like you can see the where it's extend and how it's deriving and from which it's deriving, and you can also see the outdated memory. Let me show you. You can search it like if you want to search what about Abu Hamza Khan. Okay, search it. So tell me about Abu Hamza Khan. This came from chatbot. What about if I put it Hugging Face? Okay, let me change it. If I go for LLMs, there is no memory is showing right now, but we can add a memory from there. PDF. What if I choose my resume? So you want to create a memory. Okay, there is some error, but I'm going to fix it in the code base. And this is I created a knowledge graph statistic. You can check relationship types, update, extend, derive, and you can refresh it from here. And this is the mem machine test. You can test it. You can get all session, and this is for advanced search. And these are the use cases, knowledge base. Like you can do push it from there. Okay, so the document is uploaded here for the knowledge base platform. You can check graph view. So the graph is loading, and you can see the nodes. Like you can inspect any nodes, metadata, lineage, and connected memories from there. It's taking time because I'm working on a local host, and there are some issues I think in my code. And so I uploaded my project on GitHub, and it's included the architecture diagram for this project and the integration guide and script to start both backend and front end quickly. If you are exploring how to give LLMs durable, explainable memory, this project is great jumping off point. And I love your feedback or any kind of collaborators work and anything. So thank you so much for watching it.